Good morning. So today we're going to discuss how to graph piecewise functions. Now, piecewise functions, when I first saw it as a student or even like a teacher, I was like, whoa, what is that? It's a lot of information within one function. Well, we're going to break it down and make it quite simple for you today. So a piecewise function is literally different pieces of graphs put onto one main graph. You can see graphs several different ways. You can see one continuous line with several straight lines included, which connects. Or this graph today will have a couple different lines which actually don't connect, but are all found on the same graph. So this right here, fx, and then we have a little brackets here, and we have all kinds of information over here. Essentially what this is it's one function broken down into three sub-functions. As a matter of fact, this first part, right before the comma in each, is actually what we're going to be graphing. So this part is called our sub-function. All right, that's our sub-function. Basically, this is nothing more than linear equations that we're going to put on the graph. The second part over here, this is our domain. And if we remember from class, domain simply means all the possible x values. So this is going to be our limitations on how big we're actually going to make the lines. Or initially, when we graph it today, we're going to start off with a continuous line, but then after we graph it, we're going to look at our limitations or our domain and figure out where it stops and where it starts and where it stops. So let's get to graphing. All right, so I've broken it down into different colors. We're actually going to make three different lines on this graph today. So the blue is our very first sub-function, so to speak. The fx out here and the bracket basically means f of x or y, because remember, f of x and y are the same exact thing, equals whatever the sub-function is. So literally, if I wanted to graph this very first, the one in blue, that's just like saying y instead of f of x equals x plus 3. So we can graph that, right? I mean, that's a simple slope-intercept form. I don't have the ninja one up here. It's the one that's there, but we just don't see it. But that's slope-intercept form. So that's pretty easy to graph in slope-intercept form. I have my y-intercept, which is at plus 3. I'll go to plus 3 on the y-axis. I'll match it up with blue. It's nice and color-coded with the actual piecewise function. And then I gotta look at my slope here. The slope is 1. It means I go up 1 and over 1. I can put a line there. Up 1, over 1. Now, normally, if I was just graphing this equation, I would draw a nice little line through here, like so, and we'd be done. However, the domain tells me where the line needs to start and where it needs to stop. And these are all my x values. So it looks like the line's going to be between 2 and 4. It's going to include 2 because it says 2 is less than or equal to, with that little line underneath, x, and x is also less or equal to 4. So I just go to my graph. I go to 2. I'm going to go up to the line, right about here. It's going to include that 2, so I'm going to put a dot right there. But it says it's nothing lower than 2 is going to be on that graph. So I'm going to erase everything that's less than that. I don't need this part of the graph. This part of the graph is gone. Put that little tick mark back on there. There we go. I don't need that part. So that's the starting point. That's my lowest point on my domain. The highest point would be 4. All right, so I'm going to go over to 4. 1, 2, 3, 4. Go up to the line. Put a closed circle because it includes 4. And then erase everything above it. That's our first line. All we do is graph y equals x plus 3. And we set our limitations, or we followed our domain. All right. So the next one, the one in red. It's just like saying y equals -2. Because we don't have anything else. We don't have an x, we don't have anything else. We don't have a y, well, we actually will have a y-intercept, which is -2. So what this means is no matter what x is, y is always going to be -2. Okay, so I go to my y-axis, I go to -2, down 2, put a little dot on there temporarily, and this means we're going to have initially a straight line, a straight horizontal line which goes across. But, once again, I have limitations. So this says x can be anything that is greater than 1. Okay? Greater than 1. So I have to go to my x-axis, go to 1. Now, I would normally put a dot on there, but it doesn't say that x is actually equal to 1. It says greater than 1. So in this case, to indicate that, I'm going to put an open circle. Let me finish this up. So what that open circle means is that it's not equal to 1. It's equal to everything greater than 1. Like 1.1, 1.2, so on and so forth. Now there is no ending point on here, so I can leave my arrow on that line. Now we have our first 2 points on the line. We're piecing together our piecewise function. All right, last but not least. And this one happens to have 3. Sometimes piecewise functions only have 2. Sometimes they have 4 or 5. And it looks confusing at first, but once you actually understand what is on there and how it works, it's actually quite simple. All right, I use purple on this one. So this means f of x or y, doesn't matter, it means the same thing, equals 1 over 4x. All right, once again, this is in slope-intercept form. It doesn't have a y-intercept because the y-intercept is 0. There's no reason to put plus or minus 0 there. It's just wasting pencil or wasting your ink. So, since it's plus 0, that means my y-intercept would be right here at the origin. Then I use my slope to find out my second point. I'm going to go, remember, slope is rise over run, so I'm going to go up 1 over 4. Up 1 over 1, 2, 3, 4. Put another down there. I'm going to draw a line through temporarily. Now that's that equation, but I have limitations. Let's see if I went over far enough. Yeah, because I erased a tick mark by accident. So it is 4. Okay. So this says I'm going to go from on the x-axis from -4, not include -4, so that would be an open circle, and go like to 3, but not include 3, because that also would be an open circle. Okay, so let's go over to -4. 1, 2, 3, 4. Go down to the actual line. Put my open circle, and go up to 3. 1, 2, 3. That would be an open circle. Erase everything greater than 3, because it says it doesn't include that. And there you go. You just graphed your first piecewise function, or you got to practice doing another one in case you've done some in class. All right, so that's basically it. If you guys have any questions, please ask me in class. I'm going to make a couple more videos on piecewise functions, so I will see you soon.